I'm going to talk to you about factorizing basic expressions. So, of course, when we're factorizing, the first thing we need to do is look for any any common factors. So, essentially, the highest common factor is the one that we're looking for. So, if I write down an expression 2x squared plus 8x, we can see there are two terms here, and each term has a common factor of 2 and x. So that's what I pull out the front, and then I say to myself, what do I multiply 2x by to give me 2x squared? Well, it's just x. And then what do I multiply 2x by to give me 8x plus 4? We now have a factorized expression. What I'm going to look at mostly today is extension of factorizing, where we have 4 terms possibly, and not all the terms have something in common with each other. They don't have a common factor. So let's write one down here. xy plus 2x plus 2y plus 4. So again, if we're going to factorize, we say, where are the common factors? Well, these two terms have a common factor of x, but this one doesn't have a common factor of x, and neither does this one. So not all the terms have a common factor. So what we need to do is pair them off, put them in groups, put them together with something that they have in common. It happens that if I split this expression down the middle, these two terms have a common factor of x, and these two terms have a common factor of 2. So I can group them. If I need to reorder them, that's okay. Reorder them so they find a partner where they have something in common with, that's okay, but I don't need to do that in this case. So I'm going to just factorize each pair individually. So the common factor here is x, leaving me with y plus 2. If I pull, and this is a positive, so I'm going to put the plus sign there, I'm pulling out a positive 2 out of these two terms. 2 multiplied by y will give me 2y, and 2 multiplied by plus 2 will give me positive 4. Now what's happened here is I've condensed the 4 terms into now 2 terms. This is a whole term together, and so is this one here. And what I can see is that each term has a common factor of y plus 2. In fact, x is multiplied by y plus 2, plus 2 is multiplied by y plus 2. So I can pull out the y plus 2 as a common factor, and I have x plus 2 as the second part. And now I've got a fully factorized expression, and this is what we call factorizing in groups. Let me clear some space and I'll do another example. Okay, so now I have 2 new expressions and I'm going to factorize them. So we look at all the terms and we say, what are the common factors? Well, they don't have a factor in common. These two have a factor in common, these two have a common factor, these two have a common factor, these two have a common factor, but this one does not have a common factor with this one. So there are several options for me grouping them. In fact, I can just group them here as they are because these two have a common factor and so do these two. The common factor between these two is a. So a multiplied by b will give me ab, and a multiplied by positive 3 will give me 3a. Moving on to the second grouping, it's a positive because these are positive terms. If I pull out the common factor, which is 3, 3 is multiplied by b, and 3 is then multiplied by positive 3 to give me the positive 9. What you now see is the same situation as the previous example. I've condensed these into 2 terms, and each of the 2 terms have a common factor of b plus 3. So if I pull out the common factor b plus 3 and say, okay, what do I multiply b plus 3 by to give me this term? A. What do I multiply b plus 3 by to give me this term? Positive 3. Now it's fully factorized. I'm going to do the same with this one. Again, do I have them in pairs where they have something in common with? Yes, I do. If I just split it down the middle, both of these terms I can pull out a 5 and an n. 5n is the common factor with these pairs, so that's 3m will give me 15mn, and then this one, 5n multiplied by negative 1 will give me negative 5n. Moving on to this one, I'm going to pull out a negative factor, negative 2 in fact, because both of them have a common factor of negative 2. If I pull out negative 2, I need to multiply negative 2 by 3m to give me negative 6m. And then if I pull out a common factor of negative 1, negative 2 times negative 1 gives me positive 2. What I've now done is I've condensed it into the 2 terms with a common factor, 3m minus 1. So I'm going to pull out that common factor, 3m minus 1. To give me this term, 3n minus 1 needs to be multiplied by 5n. And to give me this term, 3n minus 1 needs to be multiplied by the negative 2. Now it's fully factorized.